Hello students, in this video we'll use Green's theorem to find the flow of a vector field over a certain curve. Let's let C be the curve. I'm just going to draw it out over here. There's the x-axis, there's the y-axis. I'm going to go from 0, 0 along the x-axis all the way over to this point over here to 0. And then I'm going to go up to this point to 1. And I'm going to go back along this line segment to the origin. So my curve is these three line segments from 0, 0 to 2, 0, from 2, 0 to 2, 1, and then from 2, 1 all the way back to 0, 0. So my curve C is a closed curve. So C is a closed curve. Okay. Now what I'd like to do is I'd like to find the flow of a vector field over this closed curve, where V of xy is a two-dimensional vector field. It's going to be what? It's going to be x cubed minus y, and then y squared plus 4x cubed. Okay, there's my vector field. And so, of course, we can write our vector field in the following way. So we can write this flow integral. Remember, there's many different ways to write this flow integral. This flow integral has the alternative way of writing it. This means exactly the same thing as the flow integral of v dot dr in some books, and it's also the same as the integral over C. If this is P and this is Q, you can break up v dot dr as P dx plus Q dy. So we see all three of these versions of what a flow integral is. Each of these represents the flow of the vector field over the curve C. Now, since I have a closed curve, I can apply Green's theorem to this problem. It's a two-dimensional vector field in a two-dimensional planar curve that's closed. We can use Green's theorem. So by Green's theorem, the flow of this vector field is the double integral over the interior of the curve C of what? Of the derivative of this function q with respect to x, so partial q, partial x, minus partial p, partial y, dA. Okay? So what is partial q, partial x? Partial q, partial x, this is going to be the double integral over this triangle. Let's call this triangle over here T for a triangle. It's the double integral over this triangle of partial q, partial x is what? It's going to be 12x squared, 12x squared. And then minus partial p, partial y. That's going to be a minus negative 1 dA. That's an area integral over here. So let's compute this area integral. So we have to parameterize this region. So let's see how we would go about doing that. So over here in this region, what did I say? What is this curve over here? So this curve goes from 0, 0 to 2, 1. So what can I say? I can say that y is equal to what? Y is equal to x over 2 is the equation of this line over here, right? So in other words, y is going from 0 up to that line, and x goes from 0 to 2. So this integral over here becomes what? Becomes the integral. X goes from 0 to 2, and y goes from 0 up to this line. This line is x over 2. Okay? Then I have a 12x squared minus 1. And then I'm going to have a what? This is our y integrals first, dy, dx. Great. Okay. Now, of course, this function 12x squared minus 1 actually is going to turn into a plus 1 since it's a minus minus. That's a plus 1. So this is going to be the integral from 0 to 2. And then I'm going to have a 12x squared plus 1 y. And then y goes from 0 to x over 2 dx. And so what we'll get is we'll get a x over 2, so I'm going to get the integral, so I'm going to plot 1/2 out, the integral from 0 up to 2 of 12x squared plus 1 times x dx. So let's integrate this, the 1/2 stays out over there, and then we'll have what? So we're going to raise the power and divide by the power of something that's going to be 12x cubed over 3, so it's going to be 4x cubed, as an antiderivative of that, 4x cubed. And then over here, excuse me, so I have what? We have actually have to distribute the x first. So let's distribute the x first. So this is really what? This is really 12x cubed plus x, right, when we distribute out that x. So what's an antiderivative of 12x cubed? That's going to be 12x to the 4th over 4, so it's going to be 3x to the 4th. 3x to the 4th over there. And that works out. And then antiderivative of x is just going to be x squared over 2. X squared over 2. From 0 to 2. When I plug in 0, I get nothing. When I plug in 2, what do we get? We're going to have a 1/2 on the outside. Then we're going to have a 3 times what? 2 to the 4th power is 16. So 3 times 16 is going to be 48. Okay, good. And then when I plug in 2 over here, I'm going to have 4 over 2. That's going to be a plus 2. Okay. There's nothing when I plug in 0. So I have 50 over 2, so 25. So the flow of this vector field over this curve is 25 by Green's theorem. Thank you very much.